All right. Now that you've tried these last two exercises, uh, let's try, let's look at the answers. To find a formula for s in terms of t, if s is proportional to the square root of t, and s is 100 when t is 50. So, okay, so saying that s is proportional to the square root of t, and translate that this way. Well, first of all, it says direct is proportional, so that's the same as just directly proportional. So we're not doing k divided by the square root of t, it's just going to be k times the square root of t. So we've got that, and then it also gives you that s is 100 when t is 50. So we've got to plug those in to be able to find the value of k here. So we have 100 is equal to k times the square root of 50. And so to get k, we just divide both sides by the square root of 50 to reduce that. And so the square root of 50 you can write as the square root of 2 times 25, which will make this a little simpler. So I'll have it as 100 over the square root of 2 times the square root of 25. And I'm doing that because the square root of 25 is 5. So you could write this as 100 over the square root of 2, that's still inside the square root, times 5. And 100 divided by 5 is 20. So you can just write this as 20 over the square root of 2. Or you could get it as a decimal if you want. So you could write this as s equals 20 over the square root of 2 times t, or you could write it as s equals 20 over the square root of 2 can be written as 14.142. Oh, sorry, this is supposed to be the square root of t. Whoops. So either of these forms are fine. Okay. Exercise 4 is a tricky one, but this is really an important thing to be able to do if you're going on to take pre-calculus and calculus, where you're going to be using this kind of function notation a lot. So if it's been a few minutes since you've dealt with function notation, this is a good place to review it because we're going to be dealing with function notation in a lot more detail in Chapter 5 and also more in Chapter 6 and 7. But let's go over what this means. What f of 6... The 6 is in place of the r here. So f of 6 means that that's equal to what you get here when you replace that r with 6. So that's what we're going to do. So the top of this fraction is 4/3 times pi times 6 to the power 3. So that is f of 6. F of 3 is the same thing. 4/3 times pi times 3 to the power 3. So that's f of 6 in the top, and then the fraction bar, and f of 3 in the bottom. Now you'll notice that most of the stuff cancels out. You have a factor of 4/3 and a factor of 4/3. So you can reduce that, a factor of pi and a factor of pi, so you can reduce that. And 6 to the power 3, I believe, is 216. Yep. 3 to the power 3 is 27. And 216 divided by 27 is 8. So what you get is 8. So yeah, that is equal to f of 6 over f of 3. Now, what if we plug in 2r instead of r? So now the input is going to be 2r. So this is going to be 4/3 times pi times 2r to the power 3. And let's see, how can you deal with 2r to the power 3? One of the exponent rules says you can write this as 2 to the power 3 and r to the power 3. And what I want to do is just, well, first of all, 2 to the power 3 is just 8. I'm going to write that as 8. But then I want to write this as, with the 8 out in front. Just to separate it, write it as 8 multiplied by 4/3 times pi r cubed. Why am I doing that? Well, because 4/3 times pi r cubed, this whole thing here, is f of r. So what this is saying is that f of 2r is equal to 8 times f of r. In other words, if the radius of the sphere is twice as big as r, the volume of that twice as big sphere is actually 8 times the volume of the smaller sphere. So that actually answers part C here. What happens to the volume of a sphere when you double its radius? The volume gets multiplied by 8. So it's not like everything about the sphere just gets multiplied by 2. The volume gets multiplied by 8. So it's kind of like what was happening with the square. It turns out that because volume is a 3-dimensional thing, and you end up with to the power 3 here, you end up getting the new volume is increased by 2 to the power 3 for all 3 of the dimensions that it's increasing in. So yeah, it's a weird thing, and I'll let you get going with the quiz on this, and I'll see you in the 5.1 videos. Have a good day.